Hello.
Morning.
Morning. All right. So, how are you today?
Not bad.
All right, good.
Just getting started. Yeah.
Yeah. All right. Yeah, let's get started. So, this week we had the Diva Worm meeting on Monday, and we talked about epithelial mechanics. Susan always brings a paper or two to the meeting she'd like to go over. So, we went over this model of epithelial mechanical feedback in cell sheets. And then we talked about macromolecular crowding and some of the biological functions of that, and the phenomenology. So you see macromolecular crowding in cell cytoplasm. So usually when we look at a textbook, we see a nice neat picture of like the organelles and the nucleus inside the cytoplasm, and then the membrane on the outside. And of course, that's not the way reality is. Reality is where we have all this macromolecular soup floating around. Sometimes it's very densely packed. Sometimes it forms these that they call condensates. And so, we talked about that. There are a lot of papers on that topic. There's also another paper that I talked about after that on archaeobacteria and how there's an order of, or a genus of archaeobacteria that they share compartments and membrane compartments, inner compartments with eukaryotes. So as you know, archaeobacteria and eukaryotes are related to one another, and then bacteria was the sort of the first kingdom of life to derive from the common ancestor. So bacteria are out here, and eubacteria or archaeobacteria and eukaryotes are out in a clade by themselves. And so you would imagine they would share some common features of cellular organization. And so that's what this paper was about, talking about how you get this sort of macromolecular crowding, sort of the origins of it there. And of course, this is not to say that this is shared with, this is maybe not the same evolutionary origin as you see in eukaryotes, but you see this phenomena in archaeobacteria. Okay, so that was Diva Worm. Then Wednesday through Friday, or yesterday, we had the ActInf Symposium. So we contributed to the ActInf Symposium. We contributed two things. We contributed a talk on spatial intelligence, and then a talk on open source sustainability, and those are both on our YouTube channel, right in the first few videos. And it was a good session. So it's, as usual, it's usually live streamed on YouTube. So Daniel Friedman, he sits there and he produces the whole thing. It's these 3 marathon sessions of like 13 or 14 hours. And, he has pre-recorded talks and live talks and panel discussions. And he puts it all together. And then eventually he takes all of those sessions and breaks them down into the independent talks. So the individual talks will be on the Active Inference YouTube channel later. But right now there are these 3 streams, one for each day. So if you go to their YouTube channel, Active Inference Institute, they have those long streams available. And so I wanted to spend the first part of the meeting kind of reviewing the symposium and going over some of the highlights that I found interesting. And, I encourage people to go there and see what they find interesting and explore. And I think it's a lot of good stuff there, a lot of interesting things. All right, so the first thing is that, we have a symposium program. This kind of talks about the different people contributing to the symposium. So we had all sorts of people who are involved in active inference in industry, in academia, and trying to find places where this has been applied. So there are a lot of places where this has been applied, everything from finance to chiropractic medicine to robotics to computational modeling to other areas as well. And so you had all these different people coming together, and they were doing their talks, very wide range of talks in the session. So as you can see, this doesn't really have the talks in order, but eventually they're going to put them all on the Active Inference YouTube channel, and they'll be in order. A lot of people here from people who are here year after year, and then people who are new and just kind of spending time in the symposium for the first time. But there's a lot of diversity in terms of the talks. It's not just like cognitive neuroscience, a lot of philosophy, of course, a lot of cognition and neuroscience, a lot of like computational modeling, a lot of philosophy. Adam Safran was giving a talk on his AI alignment work, which we'll talk about later. And interface design, different types of sort of applications of active inference, mathematics of active inference, and then Carl Friston gave his opening keynote, which we'll kind of talk a little bit about too. This is a interesting talk here. Net zero job losses from AI and other surprises emerging from citizens dreaming about the solidarity AI stack. This was an interesting talk, thinking about socio-technical systems and active inference. This is the logo for the part one for the YouTube channel. So this is the live stream. So this is something that was created for last, well, I guess for the symposium, is this virtual environment. And this is, the URL for this is pre.experience.numen.games. So someone created a virtual environment for the Active Inference Symposium. There's the textbook there. As me as my avatar, I didn't really bother to get dressed up for this shot. It's just a screenshot, and here's the Active Inference book. You can explore that book. You have seating here. It's just kind of like, almost like Second Life, where I remember being in Second Life about 15 years ago doing some academic things. We had some academic spaces in Second Life that were really interesting. And so this is sort of like that. Here's another shot of the Active Inference book. This is the symposium program. You can open, you have to hit your E button and, hold it down, and you can read the program, flip the pages. There's part of the program there. There's some courses over there, Active Inference Institute courses, so you can go over there and explore the course content. This is the Active Inference Institute logo and floating in the air here. There's a meeting room over here, the symposium legacy, a cognitive map of active inference. And then this is courses scaffolded by the Institute. Physics is information processing, active inference with the social sciences. This is more sort of a logo here. You can do all sorts of interesting things in these virtual environments. Like you have to represent space in interesting ways. So it's very interesting stuff. And I like to see this sort of thing. I don't know how this was, I don't know who made this, how this was made necessarily. They just gave a short discussion about the contents, but it's, it's quite useful. I think quite interesting. So this was another talk, the phenomenological robot. So this was, again, about active inference and applying active inference to different areas of inquiry. This is Jean-Francois Cloutier. This is a research fellow at the Institute. So the Institute supports several research fellows who are able to pursue their work under an umbrella of an institute. And he did this work with looking at robots and phenomenology and active inference. And so one of the questions he was asking in this talk was, what does it take at a minimum for an autonomous robot to learn to survive in a world it knows initially nothing about? This is a problem, of course, that a lot of AI research is interested in. This is something that's motivated world models, where you want the system to know something about the world without training it from the start. So you train the model, and then it basically only knows the things that it's been trained on. You want your robot to be able to sort of boot up in a world, figure things out, and then maybe get training later. So this is kind of a long-standing question. When I was in graduate school, we had a professor in the cognitive science program who was really on developmental robotics, and he used to have these his take on this question was to use a developmental approach to build this developmental robot. The robot would just kind of boot up and gain experience from online learning, and that was that. And, there are some successes there in that research, but this is a hard question. It's a hard problem to solve. And so, I thought it was interesting that he had this take on it. Okay, so then this is Alex Sabine, who was doing these simulations of ants. So this is Inference, Active Inference. So Active Inference. The Daniel Friedman loves word puns, and he likes to talk about the institute's affordances and all this, and he has this thing about antference because Daniel's background is in looking at ant behavior, and so this is Alex Sabine's work though, and he has this alexsabine.github.io, and this is a fixed ant colony. So these ants are all these little Markov machines that he has running, and they're running around and they're behaving like real ants. So they're reproducing biological behaviors through a computational model. This is another shot of this ant colony. So I guess if you go to this website, the GitHub.io site, you can see these animations and these simulations for yourself. But the ant is exploring the space, and they're kind of behaving like ants, I guess. So and then this is more about like sort of how this works. This is modeling a lot of the ant anatomy with a head, thorax, abdomen, 6 legs, and antenna. Realistic morphogenic movement with leg coordination and natural gait patterns. There's dampening. There are pheromone networks between ants. There's tunnel construction, multi-level chambers. So he's modeling the ant colonies, as these structures in dirt. There's collective decision making, territory and combat, and memory entanglement. So all these things, of course, pheromone networks are important because ants, when they sort of explore their environment, they lay down a pheromone. The pheromone tells other ants where to go for things, and they build this network of pheromone trails that they can use as a collective memory. So that's why he's modeling memory entanglement. And then, of course, you can model the social complexity of social insects as well. And so this kind of work looks really interesting. Here's some more about the ant colonies. He just has this sort of diagrams and descriptions, specifications. This is another thing he did, was a marine ecosystem simulation. This again is a simulation where he's looking at different types of algal growth, plankton drift, and oxygen levels with different aspects of marine environments. So you have all these different marine environments where you see collective behavior and pattern formation. I have to say this year there were a lot of simulations. So we had, in terms of software, we had the main software platforms for Active Inference. Um, I think RxInfer was represented there. Um, the there is some things on biorobotics and you know, a couple other um, people who were talking about ways that you can sort of implement active inference as a solution. And then you had these software packages or people who are doing almost like ALife simulation. So this is like an ALife simulation, and you know, this is interesting to active inference because we're interested in behavior, output behaviors, and so this is all kind of in that category. So this work by Alex Sabine, and then there's work later actually associated with what Adam Safran is doing that was also very interesting in terms of ALife simulations and you know, getting at some of the questions in active inference. So this was some of Adam's set. This is not the work I was talking about with respect to AI safety, but this is Dream to Explore. This is a world model inspired architecture. So this is Gobesh Subaraj, Arena Rish, and Adam Safran. And I think Arena was the one who gave the talk. And so this is in collaboration with Mila in Montreal. And this is Dream to Explore. So what they're doing is they're implementing this dreaming algorithm. They're doing this, I guess, as a world model. I know we've talked about this in the meetings, but this is basically that work. So Dream to Explore AIME. This is the architecture. So you have data collection, you have an agent that has an exploratory policy, you have an environment with limited interactions, you have experience, which are these parameters here, the unfortunate acronym SARS, replay buffer, which gives real trajectories, and that goes down to the world model learning, where you have this variational autoencoder, which serves as the prior, VR plus perceiver, and then reward model. So you have this representation model, transition model, and value prediction. And then those will go down to imagination-based planning, which is where you have the imagined, the actor, the critic, and the explorer. And then that goes down to an improved state policy or an improved safe policy, which then feeds back to data collection. So this kind of is a framework for AI safety, but the focus here is on learning using dreaming as a mechanism for consolidating memories and other types of behaviors. So they talk about vulnerable and embodied AI, developing AI agents that recognize and model their own vulnerability, similar to biological systems, encourages behaviors that prioritize safety and avoid harmful decisions to herself and others. Then there's unified frameworks for AI safety. So building agents based on the free energy principle to ensure agents can manage internal states, which is the world model, in response to external uncertainties, aligning with human compatible objectives and promoting safety and pro-social behavior. So that's kind of the boilerplate on that. Then there's, of course, the implications of Dream to Explore for AI safety itself, the reduced real-world interaction. So physical systems could be damaged during exploration. So we don't necessarily want them to go out and explore the world. We want them to gain experience sort of in place while they're dreaming. Human safety could be compromised by learning agents. We want to make sure the agents are fully trained before we put them in contact with humans. And expensive or irreversible action should be minimized. So the safer exploration is one of the goals of this. So the model can explore what-if scenarios in imagination before attempting risky behaviors in reality. And then the containment portion of this is that the imagination-based approach creates a natural containment mechanism where potentially dangerous policies can be evaluated and diagnosed in simulation before deployment. So this is about training agents and this view of AI safety that this training an agent, giving it information about things it's not seen before, is something that happens in this dream state. And so, it's like the machine is like dreaming, and then it wakes up and it goes about its business, fully trained in knowing what's going on in the world. So this is another approach to that question. How do you make a machine that behaves adaptively in the face of things it's never seen before? Now, this is the talk I mentioned about the economics of AI. So this is reflections on economic myths emerging about AI in the future. This is this website, cartographyofgenerativeai.net, is this person's website, and they give this talk on net zero job losses from AI, enriching learning networks for adaptive resilience. So this is just kind of about this idea of AI replacing everyone's jobs and like how to maybe overcome that or how to think about that differently and so forth. So then it mentions the 2 economic myths about AI's future impact on humanity. The first myth is AI will shrink the bad. AI will take over inefficient humans, which means, of course, humans will lose jobs. And then that's one myth. And of course, like all other technologies, there's job replacement, but there's also job creation. And then the other myth is AI will help grow the good, amplify human meaning and contribution. This is where there's a cooperativity between machines and humans. And of course, those are both myths in the sense that, they're not sort of predestined outcomes. Then talks about the science of predicting economic futures. Your future is more accurately predicted by information property clusters, networks, and meta networks in which you are in. So he has this figure from Hidalgo and Hausman from PNAS 2009 and the Atlas of Economic Complexity, which show GDP per capita and economic complexity, showing the countries as they're ranked. And then this graph here, which I can't really read the y-axis, it's basically observed growth between 1995 and 2000, or 1985 and 2000, and then growth predicted from mismatch between economic complexity and GDP per capita in 1985. So this is kind of a comparison here, and just different ways you can plot the data to show that economic complexity predicts future economic growth. And then there's this interesting graph here on the right, which is where you have over time, you have this sort of knowledge and know-how in our society's computational capacity. You have person byte, firm byte, and then you have people networks and networks of firms. So you see that people are like sort of a person byte. The maximum value for knowledge and know-how is a person byte. So if you have networks of cells, which are people, you have a capacity that reaches this person byte, which is a unit of information, I guess. And then in the networks of people, you have an increase maximizing as the firm byte, which is, a firm, like an organization or a company or something like that. And then networks of firms, so not just networks of people, but networks of these firms. And that goes beyond the firm byte and maximizes, I guess, in something else, maybe like a market byte or something like that. So this is kind of a nice graph because it reminds me a lot of the biocomplexity graphs that exist where they're looking at things like cells, organisms, ecosystems, and then looking at biocomplexity as it builds from there. So that's very interesting work. Noticed in general there was a very strong emphasis on complexity theory as well as active inference. So people talking about how they were influenced by early complexity theory, how they were influenced by current complexity theory, And a lot of these themes where people are dealing with complex systems, and they recognize they're dealing with complex systems. So it's very good secondary sort of theme here. This is a key intervention approach to AI augmented learning capacity building. And the tagline here is boost the learning capacity of all your networks. So these are nested layers of learning from, I guess, from cells, cell networks, to organs, to humans, to networks of humans. And you have these nested layers of learning in each. You go from the individual to the collective. So, the individual and the collective deal with learning differently. There's something called interlearning in the collective, which are embedded in the interactions and not the individuals. This is kind of, another kind of take on the idea of emergence. And then, of course, individuals will be influenced by changes in the individuals, even within large groups. Collective learning, by contrast, are changes in the agreements and practices between members of the collective. So, you have this difference between the individual nodes kind of learning their own things and that not propagating, versus collective learning where all the things that the nodes know are embedded in a set of rules that manage the connections between the nodes. So the rules of interaction are sort of the collective learning. The rules of the nodes or the single units are embedded in individual learning. So this is a Valgin Carlut, and his talk is Active Inference for the Social Sciences. This is something that the Active Inference Institute is quite interested in, applying active inference to different social science problems. And he's going to go over the state of the art in this talk. He talks about how social structure is the aggregate of patterns, social arrangements in society that are both emergent from and determinate of the actions of individuals. So this is where social structure is both emergent from individuals and determine the actions of individuals. So there's this feedback that is where social agents both create their social arrangements and are constrained by those social arrangements. So this opens three important questions. The first is how social structure is implemented in human minds. Then the second is the relation between social structure and agency. And then the third is how does social structure change between contexts or over time? So this is, social structure is a sort of an old idea. It goes back to Levi-Strauss and the structuralists. And the idea is, you have these structures that exist sort of outside the individual, something like culture, where, you're embedded in culture, but you also create culture. And so the question is like, how does culture evolve or come to be? And then, how do you recognize culture as sort of a unit of measurement? How does culture change? How do individuals influence cultural change? Things like that. So that's very relevant to sort of this, and it's interesting, the structural view is this French school of thinking, so he's also French, and so there's this continuity there. But it's just thinking about those kinds of questions and then bringing an active inference cast to them. So then, he does talk about active inference and cultural evolution, and there's this paper that talks about this thinking through other minds, a variational approach to cognition and culture. This is applying active inference to culture. And the tagline here is the transmission of culture is enabled by the integration of regimes of attention, is enabled by thinking through other minds. So this is thinking about cultural transmission, or how cultural structures are transmitted, say, to the next generation, or to other people, or to, just kind of reinforcing cultural norms and values. And so the transmission of culture involves regimes of attention and this sort of theory of mind. So this is kind of how they're putting this together. It's interesting that cultural transmission, of course, is also a long-standing research problem. Most notably was addressed by Dawkins with his idea of memes. And then there was a journal of memetics that was around in the 90s and 2000s, but it never really kind of persisted. And interestingly, after the journal of memetics went away, the actual idea of internet memes came to be. So, like, as that journal was failing, the actual internet meme industrial complex came, rose to prominence. So people don't necessarily use the idea of memes anymore for cultural units of cultural transmission, but it is a useful sort of, maybe less than useful because it has so much baggage, but it is a useful sort of construct for thinking about the transmission of culture. And so they offer their own definition here. This is Finding Common Grounds, an ALife inspired multi-agent simulation environment and research program for AI alignment. So in this talk, Adam Safran is going to be talking about AI alignment, but from the standpoint of these artificial life simulations. So Adam Safran right now is at the Allen Center for Discovery, which is at Tufts, and of course that's working with Michael Levin. Michael Levin's in that institute, and a couple other people. So this is kind of his take on AI alignment, but it's heavily based on these ALife simulations. We'll see. So it's like there was this main talk, and then there are some simulations that were done showing. I don't really understand fully how they did these simulations. It was a platform that they developed at the Allen Discovery Center, and I'm not sure if it's based on continuous linear or if it's something else, because it looks kind of like continuous linear, but we'll look at it in a minute. So this is, he talked about a number of things about AI alignment in the talk, but he brought up this idea of having a Bell Labs for AI alignment research, and then, thinking about this in terms of active inference. So there are a number of people here involved that are also in the active inference world. And so they're doing a number of different topics. They have someone who's building the simulations, people looking at agency and value, people looking at bounded rationality and formal modeling, multi-agent alignment, people looking at path flexibility and resilience, the mathematical modeling of value canalization. Canalization is this thing in development where things are buffered into certain channels through a developmental space, hence canalization, which is channelization. Looking at sort of that in terms of free energy landscapes. So taking it from the developmental, from the epigenetic landscape or developmental landscape metaphor to a free energy landscape. Also looking at multi-agent alignment protocols and biologically inspired architectures, artificial consciousness, affective alignment and maturity, and then effective neuroscience, AGI, and biologically inspired approaches to alignment. So this is something I think where they're looking for collaborators. I don't know, we talked about Bell Labs a couple of weeks ago in our meeting, and I don't know if he's getting at, can we harness the sort of creativity and innovation of Bell Labs? But that's what they're trying. That's sort of the mental model they're using for this collaboration. So this is their platform, Common Grounds. And so this is where they're building these ALife simulations. So they have these little agents and they're exploring the world and they're playing with these balls of different things. They have these different sensory radii as well. So they're sensing things in the environment. Like I said, I'm not really familiar exactly with how these work, but I thought they were interesting to sort of mention. So this is where you have the simulator. You can play with these simulators as video games, and then you have these benchmarks for performance. So we build an ALife simulator simultaneously support virtual worlds or games which bridge humans and AI through play. So people are playing the video games. There's a simulator where It's generating this stuff. People play these games, and then there's a benchmark. The benchmarks themselves are the social and cultural effects of AI interaction. So they're looking at how people are interacting with AI agents. And then there's this research and nurturing of benevolent embodied AI. So this is where they're trying to develop more sort of humanist AI or benevolent sort of embodied AI. That's kind of what they're trying to do here. So that's very interesting. I think the simulator and benchmarks are open access. They're going to release the game demo on the web and Steam, and then iteratively improve simulator / game / benchmarks. So this is the environment. This is a screenshot of, this is, I think, concept art actually of the thing. So they're not quite done with it yet, but they're kind of showing how this works. You have interactors here interacting with different structures in the world. And then this is kind of where they have this sensory gradient here, and they're doing things in the world. I'm not really sure how this works, but they were just giving a short demo of this stuff at the symposium. This is the scaling of body and world. And so again, you have these, like I said, it could be continuous linear based on something like that. Continuous linear is a continuous cellular automata where you have locations in the world that are sort of centroids, and then you have, they behave kind of like cells in a cellular automata. So I'm not really sure what they're doing for this, but it does look interesting. And then this is just more scaling of the body and world. And then they're doing things like looking at interoception per body parts. You have this network within the agent. You have energy levels, nutrient levels, temperature, damage. There's some record of the organ state. And basically, the AI agents have this interoceptive system, which monitors their internal state, which monitors kind of how they behave. Interoceptive control provides analogs of hormones / visceral motor system. So if the agent is interacting with things in a good way, it's feeling good. If it's interacting in a bad way, it feels bad. And then there's this whole interoceptive control system, which is based, of course, on allostasis, which will regulate the behavior of the agent. It's quite I think, an ambitious kind of approach to AI safety and agent safety. Then there's vision. So this is their visual system where, they kind of model this agent visual system as a one-dimensional array of ray hits. So it's like the rays are coming out of the eyes, or rays are going into the eyes, where there's a connection between objects in the environment and the visual system. So it's capturing all of these images or all of these points, and there's this one-dimensional set of points, like a line that kind of connects all this and gives a map of the world like this. So this is the first-person view of these visual rays hitting these different objects. So you see these green objects, and then there are these other, the body here, which is this light tan object, and then this ball down here, which is the dark green or dark brown object, and then the dark green objects are these balls here. So you can see how it's kind of mapping the visual system from sort of a side view of the eye and the interactions with objects to this first-person view. And so there are these different viewpoints that one can take on the environment, and that affects the interoceptive regulation. And then this is more concept art. This is the visual, or this is the sort of the sensory radius here. There are these interaction points with objects. There's this interoceptive network. And so you can see examples of that here. And then they want to look at varieties of life. So they look at this as a model of development and evolution. You have reproduction, where new cells bud off of old cells. And then you have communications between cells to sense and act. So it's really this kind of ALife approach to agent development, and then that leading to AI safety, because agents kind of know their own bodies, they know their own context. Here are two cooperating individuals. This is synchronous joint activity where they're vicariously enjoying a single object. They're sharing access to the object. And then this is potential future work, cooperating molecules, where they have molecular scale particle cell simulations, membranes as strings of particles, cells coupled by gap junctions. You can see them in red. Molecules of various types, information, metabolic, structural, and then this analogy of origin, modeling the origin of life in undersea vents. So you could model this sort of simulation environment isn't just good for AI safety and for agent design, but also for looking at different things having to do with cells, development of cells, evolution of cells, and the origin of life in these vesicles. And so then they talk about how all of these simulations are in 2D space, but and they don't do it in 3D space, but if you extend it out to 3D space, there are interesting properties that emerge. So rich embodiment possible in 2D continuous space. 2D is simpler, easier to visualize, computationally cheaper, but there are rich properties of 3D space that 2D space does not have. And so we may actually have good enough 2D approximations to do knotted strings and embeddings of arbitrary graphs. I guess that's the 3D space, but then the 2D space has crossover points to that. So you can capture some of that in 2D, but to capture it fully, you need three-dimensional representations. You also have these non-commutative rich rotation groups where you can map the full range of real-world motor skills to these agents. You also have a rich range of motor skills available in 2D continuous space. And there's this hypothesis in cognitive science called the grounding hypothesis, or the grounding idea, that you need to ground conceptual metaphors. So you need to have sort of a ground state for metaphors or for meaning, and they don't seem to find that in their simulations. So it's interesting that they're using embodiment sort of as a stand-in for that. So there are all sorts of things, you can look at these different representations of space and how that contributes to these simulations as well. Okay, this is another kind of shot from one of so there were a bunch of talks after Adam's talk. It was like these 2-minute talks. They had 2-minute talks and they had the longer talks. So the 2-minute talks were kind of like, on very focused topics. This is something called cross-scale agency and inner alignment. This is, I just like this picture because it was like of an amphibian, kind of had this cartoon cross-section. But this is talking about agent scale action via the collective effects of microagents and action as an extension of autopoiesis. So autopoiesis is related to action, or action rather being an extension of this autopoietic regulation. So, there were a lot, of course, everyone was talking about these topics: autopoiesis, homeostasis, allostasis, regulatory control, complexity. It's very much in the theme of the conference, or the symposium. Now we get to Carl Friston's keynote, which was actually at the beginning of the symposium. This is his. So they always give the main keynote to Carl Friston, obviously, because he's sort of the person who developed Active Inference as a tool, or at least initially. His talk was Active Inference, Learning and Selection, and this talk offers a formal account of insight and learning in terms of active Bayesian inference. So active inference is Bayesian in nature, at least according to Carl. It deals with the dual problem of inferring states of the world and learning its statistical structure. In contrast to current trends in machine learning, like deep learning, we focus on how agents learn from a small number of ambiguous outcomes to form insight. The presentation uses simulations of abstract rule learning and approximate Bayesian inference to show that minimized or expected free energy leads to active sampling of novel contingencies. This epistemic, curiosity-driven directed behavior closes explanatory gaps in knowledge and the causal structure of the world, thereby reducing ignorance, in addition to resolving uncertainty about states of the known world. We then move from inference to model selection or structure learning to show how abductive processes, so this is abduction in the logical sense, in the reasoning sense, and this is not like deduction or this is abduction, which is where you're kind of coming up with new solutions. Emerge when agents test plausible hypotheses about symmetries in their generative models of the world. The ensuing Bayesian model reduction evokes mechanisms associated with sleep and has all the hallmarks of so-called aha moments. We talked about this in past meetings, and we actually mentioned aha moments in our paper on world models and the regulator theorem. I just wanted to revisit that because I thought it was interesting. We conclude with the generalization of active model selection to simulate artificial reasoning. So this talk was about looking at artificial intelligence, going back to sort of the statistical roots in physics of artificial intelligence, statistical physics, and then moving forward to modern models. So he introduces the three phases of what he calls AI physics, which was Hermann von Helmholtz, Richard Feynman, and Edwin James. So Richard Feynman, of course, everyone knows who he is. Von Helmholtz developed a lot of the early like things like Boltzmann machines and things like that, or what would become called Boltzmann machines. And then James had this interesting relationship with what they call surprisal, or what you might call entropy, or some people call it negentropy, which is looking at sort of entropy, informational entropy, and how that relates to thermodynamics. A very interesting bit of work. I actually did work through some of James's work in the talk that we had. It was like 2 years ago. It was on the stuff we did for thermodynamics and learning. And so I'll have to pull that back up next week. But for now, just remember that James is an important person, Feynman's an important person, and von Helmholtz is an important person. So von Helmholtz has this quote associated with him: objects are always imagined as being present in the field of vision, as would have to be there in order to produce the same impression on the nervous mechanism. So this is talking about sort of visual perception, and thinking about visual neuroscience and sort of the statistical, what would become sort of known as the psychophysics of visual neuroscience, but also then leading to this sort of statistical interpretation of visual perception. And this, of course, would contribute greatly to our current AI models. And so we have, in this figure, we have Richard Gregory, but at the bottom we have Thomas Bayes. So we have Bayes' theorem. We have the Helmholtz machine and the Bayesian brain. We have Jeff Hinton and Peter Dion, Jeff Hinton, of course, developed deep learning. Peter Dion is a computational neuroscientist, and then Richard Feynman over here, who developed some of the StatMech for this. So here's Richard Feynman, here's Judea Pearl. And so, Judea Pearl, of course, is a causality person. And so this is kind of thinking about the Bayesian brain. So this is a model of the Bayesian brain where you have sensory states encoded in S dot, the brain encoded in mu dot with internal states, and then active states with A dot, and then there's a feedback between active states and internal states, and then active states produce external states, or eta dot, and then external states contribute to sensory states, which then contribute to internal states. So you have these two feedback loops that culminate in internal states, producing active states, being influenced by sensory states, and then external states, or the action, is where the active state contributes to the external state, which is the action outcome, and then that sort of shapes the sensory state. So that's kind of the idea here. And there are a whole bunch of equations in there that sort of allow us to model that mathematically. Then there's the variational free energy, and that leads us to the paths of least action. So we have statements for action and perception. For action, we're trying to minimize action. For perception, we're trying to minimize the sensory states. For action, we're trying to minimize the active states. So that's how that works. And then we have the Markov blanket, which leads to the free energy principle, the path integral formulation, and that leads us to active predictive coding. And of course, we have to understand causality in that, because we have to understand what causes what. Okay, so this is just kind of like working through the math here. There's expected free energy, variational free energy, and then that's that model. Introduce that. Then the Helmholtz decomposition, which contribute to gradient flows and predictive coding. So this is just kind of thinking about some of the math that Helmholtz introduced that allow us to minimize prediction error and produce this percept of this howling wolf in this case from an image that's sort of grainy and noisy. And so we can take that prediction error and minimize it and come up with a conscious percept, a very specific conscious percept. And sometimes we can do this improperly, which is sort of the minimization aspect of this. You minimize your error. Sometimes you converge upon something that's wrong. So we could say that the wolf is, this isn't a wolf, this is a dog, or this is it could be a rabbit even if it's like ambiguous enough. And then this is Jane's work. So this is the free energy and maximum path entropy principle. So this is Jane's work on minimum entropy production, the minimum entropy production principle, which was published in the Annual Review of Physical Chemistry, where he talks about maximum path entropy being equivalent to minimum entropy production. So this is where you have this path entropy of the different paths taken through the world, and then that leads to minimum entropy production, which is this sort of maximization of sort of efficiency, the minimization of error. And so this is the equation that he states here. There's this constraint, there's path entropy, and then that's greater than the entropy of the system. So this is all to say that this is useful in looking at free energy minimization, and it also relates to optimizing deep learning networks, because remember, deep learning networks are about minimizing your error and doing this on a gradient. So we have the similar mathematics with a similar sort of statistical structure we're working with. I don't know if people tuned into the live stream. It was definitely an interesting time, and any comments or questions about this stuff, or anything that you maybe wanted me to cover and I didn't.
Oh, that was great. I mean, thank you for the summary. I didn't get to catch all the talks, but I did catch you live.
Oh yeah.
I was gonna say. So that was yeah. Unfortunately, it was just a super busy week.
Oh yeah.
And yeah. So good stuff. And how about I'm always wondering if there's I mean, I take it Chris Smith didn't speak.
I don't.
No, sorry. No, what am I saying? It's not Chris Smith. I mean, so Carl was talking about very active inference things, not necessarily in relation to computational psychiatry directly.
Yeah.
Yeah. I'll look up the guy's name in just a minute.
Oh, okay. Yeah.
Sorry, I'm actually just heading to the store here.
Okay, yeah, that's fine. Yeah. So I mean, there were, I guess, whoever kind of wanted to give a talk gave a talk. Like there were people in the active inference community who weren't there, obviously, but I don't think the person I think you're talking about gave a talk there. Um, and a lot of it was sort of application driven, like software platform driven. There was some, of course, like Carl's talk was very theoretical and talking about sort of the roots of some of these concepts. And so, yeah, I don't know. I don't think the person you're thinking of was there.
To register, they ask you like what you're coming for, what you're hoping for.
Yeah.
and I'm always hoping for computational tutorials.
Yeah. So they did have some of that. It was like there was a person named Octopus who did a tutorial on sort of mathematics and mathematical learning. It wasn't really deep active inference tutorial, but there were some other. They didn't really have any like tutorials or you could follow along otherwise. It was kind of like just showing the software and showing what things can be done. It's something it's hard to kind of pull off in a live environment. So, but yeah, I would like to see that too.
Totally. I mean, definitely, I get that too.
Yeah. So yeah, I don't know if Jesse, how are you?
I'm okay. I appreciate the recap as well. It's been a surprisingly busy week. So I was curious about Adam's presentation, I suppose.
Yeah.
I was able to see, I think we talked about him a little bit last week, but I didn't get, which day was he on?
I think he was on day 2.
Okay. Yeah, it's so interesting. I feel like I'm always on the cusp of certain conversations with or around his material, so I might look more into that as well.
Sure, I think it was day 3. Now that I think about it, right? But yeah, it's like he did the well, it was all AI safety work. The first talk was on the stuff with Arena Rish. That was on world models, and I assume that's going to be in the world model special issue. And then the other one was this stuff on ALife simulations. So the simulations where they have the agents that are interoceptive and all that. I think this follows up from last week where we kind of talked about some things about productivity and AI agents and that. Maybe it was a couple weeks ago, but this is an interesting article from Ethan Mollick. This is real AI agents and real work, and I think it's off of a Substack or something like that. This is the race between human-centered work and infinite PowerPoints. So this is about kind of the thing about, replacing workers with agents and things like that. And I think he's done we did another article that he wrote about similar to this on thinking about, how easy is it to replace people with agents. And so that's kind of the idea here. He starts off saying AIs have quietly crossed a threshold. They can now perform real economically relevant work. Last week, OpenAI released a new test of AI ability, but this one differs from the usual benchmarks built around math or trivia. For this test, OpenAI gathered experts with an average of 14 years of experience in industries ranging from finance to law to retail and had them design realistic tasks that would take a human expert an average of 4 to 7 hours to complete. You can see all the tasks here. He has a link to the task list. OpenAI then had both AI and other experts do the tasks themselves. A third group of experts graded the results, not knowing which answers came from the AI and which came from the human, a process which took about an hour per question. It said this is an example task where you have these different types of tasks for doing business strategy and other things like that. I think these are legal topics, so like they have a paralegal or a lawyer preparing sort of different types of forums and things like that. And so and then they had the AI doing it. And so then they had these different AI models, so ranging from GPT-4o to Grok 4 to Gemini 2.5 Pro to O4 Mini High model to O3 High to GPT-5 High to Claude Opus 4.1 with their win rate percentage. And then this is 50% is parity with industry expert. So Claude Opus is coming close to the industry expert. And then that's like in the best case scenario. So human experts won, but barely, and the margins vary dramatically by industry. Yet AI is improving fast, with the more recent AI models scoring much higher than older ones. Interestingly, the major reason for AI losing to humans was not hallucinations and errors, but a failure to format results well or follow instructions exactly, areas of rapid improvement. If the current patterns hold, the next generation of AI models should beat human experts on average in this test. Does that mean that AI is ready to replace human jobs? So we have all these different things that they tested. So human experts versus models, first line supervisors or production operating workers, industrial engineers, mechanical engineers, shipping, receiving, and inventory clerks, software developers, project management specialists, lawyers, computer and information systems managers, financial managers, medical secretaries, nurse practitioners, registered nurses, personal financial advisors, securities, commodities, and financial services, sales agents. So these are all kind of just some of them are, the models are above human expert level. Some of them don't really meet anywhere close to human expert level. And then the tests that they give them are, I don't know how accurate those reflect the actual day-to-day work that these professionals are doing. But they gave, in any case, this is the benchmark. So his conclusion here is that no, at least not soon, in terms of AI replacing human experts. No, at least not soon, because what was being measured was not jobs but tasks. So this is what I mean, that you have these benchmarks, they don't necessarily reflect the day-to-day work that the experts are doing or the knowledge that they're employing. So our job consists of many tasks. My job as a professor is not just one thing. It involves teaching, researching, writing, filling out annual reports, supporting my students, reading, administrative work, and more. AI doing one or more of these tasks does not replace my entire job. It shifts what I do. And it cannot substitute for all the complexities of my job. I gave the new Claude Sonnet 4.5, to which I had early access, the text of a sophisticated economics paper involving a number of experiments, along with the archive of all the replication data. I did not do anything other than give Claude the files and prompts that say replicate the findings in this paper from the data set they uploaded. You need to do this yourself. If you cannot attempt a full replication, do what you can. And because it involved complex statistics, I asked it to go further. Can you also replicate the full interactions as much as possible? And so this is where you're getting into these sort of how Claude is going to sort of reproduce this task. So without further instruction, Claude read the paper, opened up the archive, sorted through the files, converted the statistical code from one language, Stata, to another, Python, and methodically went through all the findings before reporting a successful reproduction. I spot checked the results and had another AI model, GPT-5 Pro, reproduce the reproduction. It all checked out. I tried this on several other papers with similarly good results, though some were inaccessible due to the file size limitations or issues with the replication data provided. Doing this manually would have taken many hours. So it cuts down on the amount of time doing these kind of rote tasks, and its accuracy is pretty decent. But the revolutionary part is not how I saved a lot of time. it is that a crisis that has shaken entire academic fields could be partially resolved with reproduction, but doing so requires painstaking and expensive human effort that was impossible to do at scale. Now it appears that AI could check many published papers, reproducing results with implications for all of scientific research. There are still barriers to doing this, including benchmarking for accuracy and fairness, but it is now a real possibility. Reproducing research may be an AI task and not a job, but it might also change an entire field of human endeavor dramatically. So this is possible because AI agents have gotten much better very quickly. So again, agents, generative AI agents, have helped a lot of people do tasks since the original ChatGPT, but the limit was always a human user. AI makes mistakes and errors, so without a human guiding it on each step, nothing valuable could be accomplished. The dream of autonomous AI agents, which, when given a task, can plan and use tools to accomplishment, seemed far away. After all, AI makes mistakes, so one failure in a long chain of steps that an agent has to follow to accomplish a task would result in overall failure. So, however, this is not how things worked out, and another new paper explains why. Maybe we'll get to that paper in a minute here. It turns out that most of our assumptions about AI agents were wrong. Even small increases in accuracy in new models are much less prone to errors, leads to huge increases in the number of tasks an AI can do. And the biggest and latest thinking models are actually self-correcting, so they don't get stopped by errors. All this means that AI agents can accomplish far more steps than they could before and can use tools which basically include anything your computer can do without substantial human intervention. So this is a graphic that says 4 reasons why agents are suddenly viable. The first is that thinking enables execution of long tasks in a single turn. So this is task length in terms of steps. And then these are the different models. So GPT-5 has a task length of like 1,000 steps. Claude 4 Sonnet goes up to like 470 or 480. Grok 4 goes up to like 250. And then you see a decrease over the other models. But you have this sort of, I guess there's no thinking, chain of thought and thinking. So this is kind of showing this, how this is implemented in different models. The second point is that larger models are more prone to self-conditioning. So you have this turn 100 accuracy on the y-axis, number of parameters. So as you go up to 32 billion parameters, you have 0 errors in context in green and 50% errors in context in pink. And you can see that there are these fewer errors in context in the 32 billion parameter model and more 0% errors in context for that 32 billion parameter model. So as you're increasing the number of parameters, your 0 errors in context is going up, and then your 50% errors in context is also going up from the 4 billion to the 14 billion parameter model, but for the 32 billion parameter model, it drops. And then the third point is diminishing gains on a single step can lead to exponential gains over a long horizon. And then this shows kind of step accuracy for model release dates. So step accuracy is improving. And then task length is also improving dramatically over time. And then the fourth thing is scaling model size enables the execution of longer tasks. So we have task length on the y-axis, model size in terms of billions of parameters on the x-axis. And as we move towards 30 million parameter models, our task lengths get longer. And so they can encode more steps and they can do self-correction and things like that. So this is interesting that the one of the few measures of AI ability that covers the full range of AI models in the past few years, from GPT-3 to GPT-5, is Metter's test, which is from measuring AI ability to complete long tasks. Metter's test of the length of tasks that AI can accomplish alone with at least 50% accuracy. The exponential gains from GPT-3 to GPT-5 are very consistent over 5 years. showing the ongoing improvement in agentic work. So this is a time horizon. This is for Meta. Time horizon of software engineering tasks differ for different large language models, can complete 50% of the time. So this is where you can look at sort of these this time. So the task duration for humans in terms of time, 30 minutes to 2 hours, and then these specific tasks and context. So, for example, training a classifier will take a human just under an hour, or finding a fact on the web will take about 10 minutes, or fixing a bug in a small Python library will take around an hour and 15 minutes. Scraping a record from a website with anti-bot protection will take about an hour and 45 minutes. So those are the human tasks and their duration. And then, the idea is that this green dotted line is sort of the trend for all these models. And the models here, the sort of the dots for these models shows when the model can perform that task correctly at least 50% of the time. So you see that as over time, that goes from almost no human tasks to these tasks that take a little over 2 hours. And again, these are all kind of, we can do a lot of things like in 2 hours, and it's like that's kind of a arbitrary time window, because you could write a song in 2 hours, or you could write a song in 10 hours, or you could do a lot of things in 2 hours that aren't, say, as computationally easy as some of the tasks they list here. They're really listing things like, code maintenance or something like that. So this is not like, and then like finding a fact on the web is interesting, because like finding a fact is pretty subjective, depending on the fact and depending on the person, I guess. So yeah, this is all kind of just giving some context to these benchmarks. But again, the point is that these models are performing better in terms of like being able to do complex tasks, let's just say. They had some activity here in the chat.
I'm just writing the chat.
Oh, yeah.
When you're done, I'm just making notes.
Yeah. Oh, yeah. All right, yeah. So back to this. So how to use the AI to economically valuable things. So agents, however, don't have true agency in the human sense. For now, we need to decide what to do with them, and that will determine a lot about the future of work. The risk everyone focuses on is using AI to replace human labor, and it is not hard to see this becoming a major concern in the coming years, especially for unimaginative organizations that focused on cost-cutting rather than using these new capabilities to expand or transform work. So yesterday I gave my term, every term I give a automation lecture in my project management course, and I was making this point yesterday quite forcefully that there is this aspect of how you implement automation. Do you implement it just for cost cutting, or do you implement it for some sort of synergy, or really thinking about what you can get productively out of automation? And a lot of times when you just implement it for cost cutting, you end up spending more later to fix things or to kind of figure out exactly the use case you want. So, this is an important point about like replacing people with machines, is that with AI systems or with other types of automation, sometimes we just kind of throw automation at problems and try to hope they go away. And that's not the way that, responsible organizations should behave. Go ahead.
I was going to say, technical.
Yeah.
Everything you were saying.
Yeah.
Sorry.
It's fine.
It's very loud.
But there is a second very likely risk about using AI at work, using agents to do more of the tasks we do now, unthinkingly. So as a preview of this particular nightmare, I gave Claude a corporate memo and asked it to turn it into a PowerPoint. And then another PowerPoint from a different perspective, and another one. So the nightmare of the PowerPoints, basically. which is bad enough, but then when an AI is doing it, you know. So this is the PowerPoint Mega Collection. You now have 17 unique PowerPoint presentations covering every angle of your AI transformation strategy. This is your complete PowerPoint arsenal. It sounds like hell. So you get 17 different PowerPoints using the strategy, all different sorts of like corporate speak and, you know, different types of takes on it. This is just too many PowerPoints. So this is like, you know, I want to take on X or something or on Blue Sky, and I get it because, not because I asked for it, but because people are offering it to me. So yeah, this is not really, we don't want all of this sort of stuff. We just want like maybe one thing, or, you know, we don't want to waste a lot of time, or we don't want to generate a lot of things that are kind of mindless. So if we don't think hard about why we are doing work and what work should look like, we are going to drown in a wave of AI content. What is the alternative? The OpenAI paper suggested that experts can work with AI to solve problems by delegating a task to an AI as a first pass and reviewing the work. If it isn't good enough, they should try a couple of attempts to give corrections or better instructions. If that doesn't work, they should just do the work themselves. If experts follow this workflow, the paper estimates that they would get work done 40% faster and 60% cheaper, and even more importantly, retain control over the AI. Agents are here, they can do real work. It is valuable and increasing, but the same technology that can replicate academic papers in minutes can also generate 17 versions of a PowerPoint deck that nobody needs. The difference between these features isn't in the AI, it's how we choose to use it. By using our judgment and deciding what's worth doing, not just what can be done, we can ensure these tools make us more capable, not just more productive. Okay, so that's good. Now, I have a bone to pick about this particular point about the PowerPoints, is that nominally we don't need 17 versions of a PowerPoint deck. We also don't need 1,000 different takes on some event. But the thing is that that's cultural production. That's actually what we get when we have something that happens and then we want to know what the meaning is, or we want to have like we want to kind of, say we want to measure the zeitgeist of a recent event. And we go to social media to do it. So we go and we look at the different posts, and we get a collection of posts, and they're all different. Sometimes they converge upon the same take. You know, I think you know what I'm getting at. And then, you know, sometimes they're different takes. We could classify those takes into like, you know, different ways of viewing an event, different things people focus on, et cetera, et cetera. And that's like kind of part of cultural production. I mean, we kind of unpack things, and there's multiple layers of meaning and things. And, you know, when you see 17 versions of a PowerPoint deck, you think, well, that's overworking and that's overproduction. But really, that's important for sort of cultural production, because, you know, you need to have all of those different takes to fully understand the significance of something. And so maybe not in terms of overproducing PowerPoint decks, which no one needs, but in producing different takes on things or different perspectives on things, that could be useful. So I just wanted to make that point. It's not directly relevant to the comparison he was making, but it is worth thinking about. And so this is a paper from the arXiv, and this is the illusion of diminishing returns, measuring long horizon execution in large language models. And then this is about this problem of sort of the illusion of diminishing returns. So, you know, thinking about the returns that large language models yield. So does continued scaling of large language models yield diminishing returns? In this work, we show that short task benchmarks may give an illusion of slowing progress, even as marginal gains in single-step accuracy can compound into exponential improvements in the lengths of tasks a model can successfully complete. Then we argue that failures in large language models and simple tasks are made longer, arise from mistakes in execution rather than an ability to reason. So this is where, again, you have this, the more steps you have, the more executable steps you have, the more you can correct your mistakes and so forth. So it's not that the models are making execution mistakes, or they're making execution mistakes rather than this inability to reason. So we propose isolating execution capability by explicitly providing the knowledge and plan needed to solve a long horizon task. So there's, of course, the knowledge and the plan. First, we find that larger models can correctly execute significantly more turns, even when small models have near-perfect single-turn accuracy. We then observe that the per-step accuracy of models degrades as the number of steps increases. This is not just due to long context limitations. Curiously, we observe a self-conditioning effect. Models become more likely to make mistakes when the context contains their errors for prior turns, or from prior turns. Self-conditioning does not reduce just by scaling the model size. But we find that thinking mitigates self-conditioning and also enables execution of much longer tasks in a single turn. We conclude by benchmarking frontier thinking models. So they're now focusing on thinking models on the length of tasks they can execute in a single turn. Overall, by focusing on the ability to execute, we hope to reconcile debates on how large language models can solve complex reasoning problems, yet fail at simple tasks when made longer, and highlight the massive benefits of scaling model size and sequential test time compute for long horizon tasks. So this just kind of underscores what Ethan was talking about in the article about this, this number of steps that the model can take and the kinds of tasks that it's asked to perform, things like that.
Is this mic on your end, or is it still kind of the same?
It's. I think it's okay.
Okay, I'm trying to just have it feel less crazy. No, that's good. That brings up quite a few points. I find a lot of this it's kind of frustrating. Like just to have a straight reaction. It's so. I feel like I'm just inundated all the time with people talking about how AI is affecting work and AI is affecting work and AI is affecting this, and I find it to be like that. Like there's I'm discontented at the lack of sort of what's around the corner from it. Like it always seems to just be, well, the models are getting better at this, and there's no real. And I think there are, and I just some of it's not centered and it's not as popular, I suppose. But really, just like what if the models do get better, like how does that actually change the structure of things? And I don't need to go into full like UBI talk or that kind of stuff, but it it strikes me as sort of there has to be a certain kind of disingenuousness to it that it feels. And that's not a commentary on Ethan's post and Ethan's intention and job is to report on the model's development, and I think that's exactly what he should be doing. But there's sort of this and this is a preview and a segue into other things where it's just I find there to be and then maybe I'm identifying the niche I want to do more in and doing more in and want to speak more about in this my complaining about stuff. But I find it very interesting. Like yes, like models are getting better at this specific thing, and I don't think it's just a matter of unoriginal workplaces. I think yes, like the implementation right now and why many people's jobs have already been affected by this is because let's cut costs, and if I can pay this for that and have this thing, there's this meta from the workplace down to content consumption. There's sort of the lacking of, it's just sort of a result. Well, if I get the thing that looks like the success, then it's success. Then it's the results. Then it's work. Then it's labor. And so I don't know. That's my initial raw reaction. I think it's the least helpful thing to really comment on. But I do think I'm very fascinated to see, where are the transitions? Like where is the real talk about, okay, models are better, and what is on the other side of that? At any rate, I would definitely be interested in the automation portion of the lecture you mentioned. I know you periodically do that, and that's something that's, and even the sense of one of the speaking or panels I'm facilitating, running next year, which is only a few months away, I suppose, in one light, believe it or not. I would appreciate being able to sort of convey I would invite you to sort of be a part of that directly, but I think it will be very in person. But we'll see if there's a way to do it. But like basically what, as in the context of that panel, it would be, you're a young person, and how do you deal with implemented augmentation that you'll likely experience in your job? Because that's, what the point of that panel is essentially going to be, how do you deal with Gen AI and automation and, as an early career worker, researcher, individual? So that's certainly a, what are we doing about it? And what can we do, and what should people be informed of, type of thing. And I'm just looking back to the chat here if there's other notes that I made. You mentioned something about fact finding according to which person. I think, yeah, like the reality is now we're in. It's kind of I think we all here are familiar with sort of the personal universes notion of AI safety and Polsky and where that came from and so on. And I feel like I'm not sure people really, maybe they have, but I think we're kind of very close to not just personal universes. You can have your personal social media platform, which also now, like I'm alluding to Elon Musk and Twitter and Grokpedia, and like you can have a platform and your truth, your AI enhanced, your AI generated or refined or revised, or your particular tint or whatever for your knowledge base too. Like it's social, knowledge base, and community, and perhaps an interesting segue to other things that I'm going to talk about. What I will cover or move towards, and feel free to jump in and comment or say whatever as I do this. I'm going to talk a little bit about my exploration into pattern language as a concept, as sort of a domain agnostic concept. My particular take on language models and artifacts, which is this thing I've been saying for years, and I'm trying to codify and put into a specific paper eventually, and then I'll move towards, it's sort of a background theme, but then I'll share this. I'll go through this. I had a sort of a post that I pushed them like the Substack type things, and it just goes through a whole bunch of stuff that's been happening this week and kind of in and around the community. And it's literally just an immediate snapshot, because there was so much I just wanted to mention, from the complexity group to Ecolopto stuff, to plot pushers, to local things on governance and nation stuff to moral ambition to some stuff happening in San Francisco. And I mentioned Frontier Tower because there's so much stuff happening there, and I don't know what to comment. I just threw it in there. So I'm sure Morgan has things to say about Frontier Tower at some point. And then also, yeah, like a little bit for next year, because it's already kind of that transition into the next year for all of this stuff. So before I get into that post, is there anything? I guess I'll be on camera. I'll be on camera for a moment. Is this going to work? Yeah. I'm in my magic background in Boston. How about that? Any comments or questions before I kind of go into pattern language stuff?
No, I think that's good. Yeah, I think that's, I don't know if you were here when we were talking about the AI work talk at the Active Inference Symposium. He's basically going through, yeah. So maybe you can review that in the recording, or the talk I think is in one of the days of the symposium, where he basically goes over the sort of the economics of AI and work and all that. So it's interesting. Yeah, but I think that's again, something that it's kind of like that futurism take, right? It's like we have the futurism take where people try to predict things in the future, and a lot of times they get them wildly wrong because, that's just the nature of futurism. But how do you make those predictions more accurate?
Yeah, and I think I have this internal urge to put a bow on what I said and make it a little more coherent and less just, I don't know, less complaining about stuff. But I find there to be a certain awkward discreetness about some of the conversations. And again, it's not anything wrong with the article, the discussion. It's more the stopping point seems strange. So let's move on. I just have to get away from it because it's gonna waste my time and trip me up. So let's talk about pattern language for a little bit. I will attempt to. Yeah, I'll go to. I think I mentioned this at the very end of last week. Sure. I just updated an operating system, and now like all the permissions are like we have to go do this again. It's like okay. Maybe well, let me try it this way. Hold on a second. Sorry. Yeah, let's do separate. Here, sure. I think this will work. Yeah. Okay. Multiple screens. Wikipedia was just a dream. In terms of pattern language, a little personal background on pattern language is that it's something that came up through plot twisters, which I'll mention again in a minute. We had our first playtesting session, and it went really well. But more about that soon. Pattern language is something that I learned about through plot twisters, which is kind of co-founded by a couple people heavily based in design. Design students, Jenny Luzang is a designer on many fronts and a wonderful visionary and designer. And I think I first got the idea of it through her and some of her thesis writing type things, and eventually plot twisters proper. And I I kind of got it and appreciated it, but now I realize I'm taking a deeper dive into it, into both what it is, how it came about, and its cross-domain applications. And it's sort of, there's sort of this interesting tension I'm going to build to of like pattern language versus kind of meta science or meta science almost as like top-down categorical philosophy of science type stuff, and then pattern language as this generative, almost a gentle, and one of the things somewhere in here, somewhere in here, there's a reference to Alexander's work. The work is essentially, it's really a series of books, and I do agree that you can't really it's not really, this is the book that everybody references a pattern language, but it's also about the first book in the series, which is something about like the timeless way of building, and that reads quite a bit like a lot of Zen koan or Zen scriptures, like Zen Lessons, The Art of Leadership has this sort of poetic ways of discussing a variety of topics, and in it he gets at quite an interesting set of demarcating spaces within, you could say, a problem space, and then different levels of patterns, and I would say topics like emergence. Like I don't think it's about emergence, but the concept of emergence is quite embedded in it. Also, like things related to the embodied mind. I don't know if Christopher Alexander was savvy to Varela and that whole thing there, but it's quite related to a lot of the concepts of parts of Buddhist influence on the embodied mind, and also sort of the sense that the Buddhist Chen stuff about, it's not about a dogma, it's about that which completes. There isn't always a right answer, it's about doing the thing which makes the outcome as it should be, which is sort of, related to this. So where am I going with all this stuff is like, pattern language has been very influential on programming. It's been influential on the curriculum design, which is kind of what I'm looking at particularly recently, is like papers on, I don't know if I can pull one up easily here. I have it, but can I get in this window? Here. Oh, you can't. Well, let me just quickly show this. Come out of this and go to this. Yeah. So I've been looking a bit at things like this, which is like a pattern language for teacher education. I can't really manipulate this part of it. But just to introduce this briefly, redesign and teacher education programs at UCincy has been unique. Borrowed from architecture, the framework has enabled College of Education faculty, art science, public school administrators, teachers to re-envision teaching and teacher education by developing a language of practice called a pattern language for teaching. This identifies areas of knowledge necessary for teaching and specifies the process of structures for achieving the goal. The concept of developing and using a shared language has allowed us to deliberate about and incorporate goals across disciplines. So what they kind of get at here is so this is sort of an interesting theoretical basis with the ability to draw upon and orchestrate bodies of knowledge using context-sensitive skills, good teaching involves the mastery of language practice and all this sort of thing like that. And to kind of, I don't want to take too deep a dive into this paper, but it is an interesting sort of methodological approach to, Alexander, as I currently understand him, sees, I think making a pattern language is also another way of essentially mapping a problem space. Within that problem space, these recurring patterns or patterns in which things happen, which is interesting, emerge. In the original pattern language, which is a pattern language, was about architecture and things of that, of building real buildings that people would inhabit. You have, like a macro pattern is like an isolated, I forget the term, but like a collection of, a broad neighborhood, and then you have like a house or like a bath, and then a bath and a bathroom. And it's like bigger patterns that contain small patterns of smaller, things. I kind of think about it, if anybody's ever played like, one of the sim games. It's like pattern language is sort of that which enables, or like in a Fallout 4 town crafter, like you go like, okay, I want to build a staircase, or I want to build a prefabricated house. Here's sort of like, you go into that section of the menu and you pick that thing, and you then you instantiate it, and then you implement it, and then you make these adjacent things that build it out. And so I think applying this to concepts like these sort of, it's a very interesting way, in sort of a frontier map type way, to look at how do you take a vague problem space? How do you take I put here about Levin. There's an interesting sort of agential and economic component to these things, because they're essentially around what you're doing and the activity within that space. And so what does that mean for like making a pattern language around teaching? What does it mean about leading people through a demarcated space where you have, these patterns that you've identified, and then in like the third book in the series and some later works, like in this particular University of Cincinnati take is like the making a language and making a plan that's very organic and integrated into other people contributing to that language, contributing to the patterns, and contributing to the plan of action around what to do, or how to build, or how to design the thing that you're doing. So this is an extremely abridged, opening on pattern language, but I'm interested in it quite a bit because I think it can be a tool that will map, particularly in the construction-oriented sense, which is kind of my frustration from earlier things, like, okay, how do we talk better about doing the constructive work in different fields or across fields or in whatever 2025 or 2026 is? I think pattern language, as a way not just of making a language of patterns, but as a implementation affording or implementation tool for how to instantiate certain things and make some coherent language around them. I think that's a very something that will keep coming up. Like, and also, Bradley knows a little bit about this, and I've spoken kind of vaguely about this in general. But like, I talk about curriculum design. I talk about things like the future center and all this other stuff, and these elements of how do we build these new things, and is it a pattern language, is it a curriculum, is it a teaching, is it education, is it perspective, all of those things, which are challenging and on the table. I know we're kind of, I might kind of have this be like a part 1 or a part 0 to another discussion that we talk about next time, just to move on to other things. But I'll pause for any comments or questions before we basically go into to this, the kind of news, broader updates from this week. So.
Yeah, that's good. Yeah, of course, as you know, that it's not that we just use pattern languages in like education or in architecture. We also use it in programming, and that's actually a place where it's interesting because you apply this like to sort of a functional. You can apply it immediately to a functional setting. Like you can use patterns in programming and use them to sort of improve coding, and you can measure that pretty easily. And so it's a good empirical test of pattern languages. Obviously in architecture where it originated, and then of course in education where I guess what they're suggesting is that these 5-year plans, these 10-year plans are useless. You need to have like a more organic type of bricolage of things that are possible, so you can shift and as long as things conform to the overall pattern, then that's fine. Actually, pattern language probably is also useful in project management. I didn't even think about that as an application.
I think we could have some really fun conversations, and I would be totally open to trying to structure them this way around both, essentially, like in the arena of like you could say a programming language is sort of a pattern language. It's inherently, but like because you're both doing data structure, the library structuring, like maybe data structure, the way you're structuring what you're trying to do in the language, and what is the activity or the economy of it? Well, programming languages are about computing. So you're doing the compute that transforms the thing by which the input is being changed into something else, right? And I think it's an interesting lens and kind of one that's a little bit separate from other ways that we do this stuff. And so yeah, absolutely, for like you take it for project management, you take it to curriculum design, you have these other sort of computation, and this is where I'll kind of shout, like I will try to tag this and say for Addy and the computational philosophy salon type stuff, like this is something we could talk about. I'm very interested in leading discussions about this and that space. But project management, doing things in the world, curriculum, we have this sort of computation adjacent activity, and usually computation in the sense of how to moving between states, moving between, okay, here's the initial state, initial input. What is how do we, even just the demarcation, no less the actual like computation of going between the states towards a specific development or towards a specific end. And similarly, Bradley mentioned not just the 5-year plan, but there's, and why I mentioned the little 11 a gentle bit is like there's an implicit valuing or professed valuing of organic sequential development and doing one of the components at a time and then building organically adjacent, as opposed to this sort of, I would say basically inorganic, top-down imposition. This is the structure. Whereas like, no, it's like, how does it emerge in more of a biologically connected, I don't want to say embryogenesis, but like this sort of generative, feels very biologically generative. That's sort of like in the building process for like design or curriculum in that case, or building the thing. You don't just like cut everything, raise it to the ground, and then just immediately put a brick here, to brick here, to brick here, to brick here, to brick here, which is sort of like it's you're building one of the structures in a structure, or at least a plan of the structure at a time. And then there is an adjustment or a recalibration, or okay, we've completed the structure, where to go from here. And yeah, I think there's some incredibly useful ties to project management or program management or building building a town. Like, what's interesting, before we move on to the other thing here, what I'll kind of close is, like, it's really interesting to see, and I also found a lecture. I've just started, but I found an actual lecture of Christopher Alexander talking about his stuff, and he was talking to, I believe, oh yeah, it might be, we'll talk about this next time. It's a lecture where he introduces how it came about by saying a bunch of computer science nerds in San Francisco wanted to invite him to talk about stuff, and it kind of, you know, circles the topics that we've talked about here. And he's like, hey, I don't know anything about computing, but here's what I know about building things. And that's sort of how he goes into it. And it's interesting to see him talk and to see what his considerations are. And I appreciate he speaks with a useful amount of declaring inadequacy of how certain things work. And I find that to be a skill I'm desperately trying to master and not very good at yet, because I want to be able to say, here are things in a theory, in a structure, in a whatnot, in a space, in the world, that are clearly inadequate, and we need to do something better. But how do you do that in a way that's not kind of whining or sensational, or, you know, you got to offer the positives of the aspiration while also being, you know, speaking to a world that doesn't want to hear that it's wrong about what it has available, you know. So I'll leave it at that, but I think there's a tremendous amount of follow-up opportunities there. And I guess I'll move on to whatever this list is of just so much stuff. Any other final comments? I know there's a lot of things there.
I think we're okay.
Yeah. And I'll try to go through this very quickly. People can read the full thing they want. This is literally just there's so much happening this week that I wanted to just note. And I didn't even put things on like the Active Inference event, which we just covered. So I should maybe go back and add that or whatever else. But just a super quick recap of things. First, this recap, or not this recap, but this. I would recommend checking this out in the sense for people that are interested in, you know, funding, but also getting a sense of what O'Shaughnessy and company are doing. They've helped out with Ecolopto, and they've funded Addy and some other folks. And there's a certain, I appreciate Jim's openness to both not being hype oriented, but being pretty sober. Like, we had a nice conversation about people and founders and ideas being pre or post fall, and kind of the like fall as in kind of like pride before your fall, as in like, do you have a requisite humility to realize how fragile the development of your ideas and things are? Or are you kind of in this gung-ho phase about things that you need, but also like, are you sort of belligerent in your enthusiasm, or foolish? And have you you know, that was a nice part of the talk, but also just like what is structurally happening here, and I appreciate his optimism and sobriety around that. So computational philosophy club stuff is sort of happening there too. Oops. We also had a very interesting brain-inspired complexity group discussion this week. It was led by Darren Lopp, but it was cool because, you know, like Kevin Mitchell, Anna Rydell, and others, Louise was there this week. And for those that don't know, we're going through the complexity papers as identified by David Krakauer and Santa Fe Institute, and his books around that stuff. The Minsky one was interesting because, you know, it's such a landmark paper and reference. Like, Minsky is always associated with like AI winter and AI summer, and he takes a lot of blame for why, you know, you steered us in the wrong direction. And you know, this is not just that paper, but like, you know, there was even a nice discussion on steps towards artificial intelligence versus other titles around, potential heuristics that maybe lead to something like this. And the nature of titles, the nature of funding, the nature of sort of the pressure, whatever vantage point people have to communicate their idea, and the folly that may take, or just the unintended consequences or the intended consequences, and how messy it is. So that was really cool. Moving very quickly, and I think this is available somewhere. This first one is definitely available on YouTube. This happened yesterday, and it was wonderful. Oops, sorry, I'm not a small course. I didn't get to see this one, but this is sort of the machine perception and cognitive robotics lab at FAU, where folks from Ecolopta are, Will Hahn and I think Elon are both there. I didn't get to attend this directly. Was this live? Oh, it doesn't appear to be on here yet. That's too bad. But I believe this was supposed to be live streamed, about some of what they're doing in the lab space. This Small Hassles Court from Plot Twisters. This happened yesterday, and if anybody's interested, there'll actually be two more public, or there's going to be more private sessions as well, but there's two more, like, kind of, hey, we would like you to play test and talk about our ideas. I don't know the best way to show this, but basically, Plot Twisters Small Hassles Court is part of sort of a component of the game. Plot Twisters is a group of people trying to make an online or an ed tech, educational-ish, research-inspired game world that's around like emotional literacy or interpersonal development, and dealing with narratives, dealing with these important skills, and even dealing with things like pressure around how do you construct your identity and manage things in like the present shock digital age that we're in. Small Hassles Court is this sort of implementation where you would go with someone who maybe you have a conflict of some sort with, and you would resolve it and go through a different, not quite mediation, but it's a sort of a structured discussion as part of maybe the game world, and how do we both make this a useful, like modeling a useful skill we can use in the real world, but also make it interesting in terms of the game. So we did this playtesting session with a number of very interesting people. People who are vested very much in game design, people who have worked with federal agencies, people working with youth development, people who are familiar with all manner of like digital platforms and making spaces in them, and dealing with interpersonal, I won't say conflict, but interpersonal issues and matters, and how to do it. One of the things that came up in the session was court is maybe a jarring term to many, especially in the West. So maybe, Plot Twisters itself is sort of this, the approach to the game was very lighthearted and fun. You have this sort of, hokey fun, dragon person leading you through the court, but like, how do we make it approachable? How do we make it, how do we let people come into it? And we can go into more details some other time for people interested in this, but we ran this very simple scenario of two people coming to the court to discuss a particular matter, and it was very fun to see everybody's reaction, even the sense of multiple people embodying one person here, or like thinking about one person as a playtest or sort of a general demo, and then getting actual individual people to go through it and how that will be different in terms of like understanding how the playtesting should work and drawing interesting things from that. We presented on this last year at the Inclusive Gaming Conference in Oxford. It was good stuff. I didn't get to go to this in person. This was sort of what ties the nation together. I kind of give a shout out to the Stanford Center for Ethics, which is here in Cambridge at Harvard, because I think they're trying to put themselves out there a bit more. And I like a lot of what they've done. I've been to a few of their events in person, and as much as they're kind of, some things at Harvard are stuffy and removed, but they've been pretty open, and I encourage their openness. There was a Manolis Kellis does a lot of kind of salons at his house, basically. Like, he just invites people over to his house. I didn't get to go to this one, but it's in Brookline. It's outside of this. I'm not sure it yet. But yeah, this is sort of, this is with David Bennett and Resilient Mind and Brain, the community and aging. There's a lot that was going on there. I know people that went to it. It was a good time, and I know Manolis is, he's trying to sort of make his own salon spaces, and that's cool. Moral Ambition, I know there was some, he came to Boston, he's got this big bus, he's doing Boston and Princeton and Stanford, and I've almost worked with them on a certain project. I'm a fan of them. I don't agree with everything, but I think the idea of intentionally trying to give people alternatives is very much what I want to do. Like, one of the things I'm doing with the Future Center specifically is a project on how do we identify alternatives. And so I think he's doing it kind of on the ground. They're launching this fellowship for juniors at Harvard as a pilot, and hopefully other places too. But if you're a junior at Harvard, they want to basically incentivize you not to take your, not just, don't just go into being a McKinsey consultant. Let's try to give you other options to focus on bigger problems in the world. And there's a new fellowship program for that group to do that. And obviously he's got his book and all this other stuff going on here. I have a discussion around that. And the last few things in San Francisco, there's a very cool, through Joel Legan, Distress Scientist Department. Shout out to Distress Scientist Department. It's not really, that's not showing me stuff. There we go. But she has a lot of great stuff as things that are happening in San Francisco and development, and she's trying to shift all these things about. There's a gala happening of the researcher creative, which sort of, we talk about philosopher builders occasionally, the researcher creatives. And this is directly from her. I talked to her a little bit about this, but basically there's a 3-day exhibition for researcher creatives who are trying to bring their work and papers into tangible artifacts, kind of augmentation lab derived. I think I mentioned them down here. Some echoloctal stuff, trying to do sort of the creative artsy merging stuff into a gala. So if you're in there, check it out. And then I mentioned Frontier Tower at the end. There's just so much. There's always stuff going on here, so I just plugged their entire little calendar. Maybe it's a segue if Morgan wants to say anything about them. But there's everything that's happening this week, and there's also like imagination and action, climate focused stuff starting here today. I might try to go to some of those things. That's in the John Warner event. And then, yes, Princeton Envision in February, and New York Celebration of Women Computing in April. I'll be at both of those events, and we'll be doing some things with them ahead. So just tons of stuff happening right now, and I feel like it's a big blast of stuff, and everybody's going to be quiet again because it's finals and academic stuff is going to bottle up. And then we're going to go into winter break, and then it's going to come. It's going to explode again. So, any comments or questions? I know that was a lot. I know we're kind of out of time, but anything you want to say before wrapping up?
No, I think that's good. A lot of stuff going on. Yeah.
Big shout out to Plot Twisters because I haven't seen everything that's been going on in this space, but this is a nice thing that they did, and they really made. Amanda has spearheaded a lot of like the medic of putting it out there, orchestrating this stuff, and I think she's done a lot of that, and all Jenny, of course, and I don't want to forget the last word, Joanna. Those three are the main persons for it. So shout out to like that being a really fun time, and I'm looking forward to next Friday. I'm going to join the version next Friday as well, because I think it's both a fun problem to deal with in terms of implementing, and then it's cool to see what comes from it as trying to make, in one sense, Small Houses Corp in the pattern language development sense is sort of the first structure in the community being built, and then we already have links to the storytelling cards for these other things, the field of feeling, these other physical spaces in the Twisterland world, and then the actual like, what are you doing in those spaces? So it's a fun thing about it in that sense too. But yeah, that went really well, and I encourage everybody to talk more about that the next event. Here we go.
Yeah.
And I will leave it at that.
All right. Thank you. Morgan, you wanted to say something?
Well, I appreciate all the Frontier Tower shout-outs.
I'll change this to Frontier Tower in the background to be
thank you. Thank you. I mean, or identify the Boston location. It was nice. We got to.
I'll be happy to call myself like Frontier Tower Boston Ambassador. I'm sure you have many of those.
Well, I'll send you a link for the Telegram. I think there's I don't know. There's cities that I would choose to focus on, and but like New York is the big location, and I think that has to do with basically the financing,
Right.
But in terms of like trying to find a good real estate opportunity, I would like, and I'm biased here because I've got a place in Baltimore, but I would go for Baltimore. Anyway. But did you already do the Orwell event at Stanford this Sunday?
I didn't.
Okay. And I mean, if you're talking San Francisco events, it's it's Who Controls the Future, I think is the title.
Who's that? Who's running that?
I thought it was Augmentation Lab.
Yes, yeah, it's Indira. Indira from that?
I think it doesn't say Augmentation Lab directly, and it's like anyway, but it's down at Stanford, and
here it is.
If I wasn't,
this is like supremely relevant to. That should completely be on the list. Here it is. If you're there tomorrow at Stanford, highly recommend checking it out because it's what we talk about all the time.
Yeah. Okay. It's Echolopto is the okay. Yeah. Anyway, that was the it's not San Francisco. It's South Bay. But it seems like worth mentioning.
I'm in spirit. I don't think there's a virtual component, but I signed up anyways.
Yeah, it is getting close to the holidays, and so at this point, I mean, everybody's got their sights on SFN right now, right? Because that's the So it's like a lot of last week was actually conferences that full conferences that are run as pre-conferences to SFN, right? Yeah. So NER is the big brain implant conference, which is run by IEEE EMBS, and there's also the International Society of something like Developmental Psychobiology, where the electrical geodesics goes because their high density EEG systems are widely used with kids because they just use little sponges instead of using paste, things like that. Anyway, but that's a really interesting meeting if you're interested in developmental neurobio, right? We've started the flex session for the connection, the camera, working with students in Ghana, or at least my team's in Ghana. So we have a real data set to work with from now until January 23rd. So I don't think that means that there won't be any conflict on Saturdays. I don't think.
Okay.
But looking forward to that. And so even though everyone's sites are on SFN, and there's definitely some interesting things that are I'm looking forward to some announcements, as well as getting to see, at least hopefully, people taking pictures of posters and posting them. Just my sites are on the next San Diego meeting, which would be NeuroSim, and the workshop around NeuroSim. So that's what San Diego.
Yeah, I don't know. There was a version where I was going to be out in San Diego basically this in November for some things, but I don't think I'm going to be able to do it. I had some things here that I had to stay here and tend to, some emergencies as well. So are you going to be going to any of those events in person yourself?
I absolutely want to catch the workshop on foundation models for, I think it's body and mind. Let me find the exact it's foundation models for the brain and body. Exactly. So it's brainbodyfm-workshop.github.io. That should be really interesting. That's going to include some of the organizers. So one of the organizers works currently at the tower. So there's that connection. But this has also got Paul Scotti, who leads the Mind's Eye team. So what was it? Stability AI, and now it's softened. Is also part of this. So they'll be talking about fMRI foundation models, electrophys foundation models, EMG foundation models. So some of the wrist actuator stuff, some of the anyway, that I want to catch, plus the EEG challenge, which is also going to be, the winner will be announced, and so it's kind of my chance to actually catch up with the people who were doing that, who also lead kind of the Neurotech X project called Moab, or as the French guys say it, Moab BB. Anyway, so those lots, and that'll probably, then it'll be some Christmas parties, and then everybody will be, that everything will be on pause until January, right?
Yeah.
Anyway, but
I think that's a question that I have. Is do you, in terms of all the events that we talk about and everything, is there basically going to be a dead period from when is NeurIPS, or?
So it's December 2nd to the 7th. So it's technically to the 2nd to the 5th, and then the workshops are the weekend.
So basically, after that, it's going to be kind of a dead period for a while because of the holidays.
There's a few things, you know. I mean, it's just like if I could, if I had a teleporter and didn't have to actually fly in weird lift-driven aircraft, I would. The eBrains conference is in Brussels, so that's that's the successor to the European Human Brain Project. I think that goes until the 11th. So it's just like, yeah, but I just can't justify being a jet setter to hit the there's also like something on the island of like I'm gonna say it's Capri, but it's not, but it's something like that where it's just like it's a bunch of virtual brain project people that are meeting on some Mediterranean island, some picturesque Mediterranean island, and justifying it as a scientific scientific workshop. But yeah, essentially, someone, the former director of Neurotech X, who's a postdoc at Johns Hopkins, sent me this cool. Sorry, one sec. Sent me this particular so this will be in mid-January at Hopkins. That is about organoids, and it's got like all the Hopkins organoid people speaking. So okay, it was 16th. So yeah, I had to check with him because I was just like, wait, do I need to be a Johns Hopkins employee? And he checked, and it is actually an open meeting. But it sounds like a great way to start the year in terms of actually getting to meet, Thomas Harding, Lena Smirnova, and the other list of organoid luminaries there. So looking forward to that in the new year, and yeah.
I selfishly asked because I'm trying to plan both for like data interaction and JoPro stuff. Like I have a very clear dead period myself, and I'm trying to think when's the best time to start it. I think it's basically going to be after the first week of December. I don't know, Bradley, do you have any like planned downtimes where we're not going to be meeting here, like in Northumberland?
Probably the last maybe 2 weeks of January or December, and maybe the first weekend. We usually take that time off, so that'll be kind of our downtime.
Okay. Yeah. That's all for me. I have to go soon.
All right.
Yeah. Sounds good.
Yeah.
Thank you all for
Sounds
today.
great. Yeah. Thank you. Good conversations, and we'll follow up on this stuff next week. See you then. Thanks. Bye.
See you.
See you. Bye.